Hi, it's the Hawaiian Coder here again, and you're back with me on my Learning Web API series. Now we're in part 3, where we're going to actually modify our data via our Web API. Let's get started. So in this video we aim to finish off the basic operations of our Web API, even though we're not using any particular infrastructure in terms of a database or any best practices. But by the end of this video you'll have the basics in place for a full CRUD operation, and that will mean that you'll be able to read data from your Web API, update data, post brand new data and delete data. From the last video we were in the state that we can currently get data out of our system, and that looks like this. We've got two methods, one that will get every player out of the system. When you execute it, it looks like this, and the second one where you can specify a particular player by passing in that player's ID, so like this. Both return 200 and a payload. So in this video session we're going to do the following. Let me just call up my code. So here's the code how we left it before, and in here in my notes, just so I don't forget, video 3. So again we're carrying on using our quick and dirty approach of not actually having a database, so we're not reliant on any infrastructure at this stage. And the first thing we're going to do is we're going to see how to add a new player to the system. And to add a new player to the system requires us to use the HTTP verb of post. So let's get started with that. So if we go to our player controller, and we'll just collapse these down so we've got a bit more space. And the first thing we need to do is use the attribute of HttpPost, like so. And then we need to create a method. Now I'm going to copy and paste the method and then walk you through it to save time so you don't have to watch me type. So here's our method that will let us add data into the system. It is using the post verb, and it is called add player. And the parameter that you pass into this add player method is a player, and a player comes from our model. So it's expecting an object or a piece of JSON that is in this shape. And a thing to note here is it is going to pass this data in the request in the actual body of the request. That's what this attribute means, whereas previously we've either not passed any data through to the endpoint, as in this call, or if we passed any data at all, it's been in the URL, which is with this call, hence this route here. But this one will pass all the information through, not in the header, not in the URL, but in the body of the request. So moving actually into the implementation of the code, the implementation is quite simple. First of all though, we need to resolve this red squiggle. And the reason we're getting a red squiggle is nothing to do with web APIs, but all to do with the fact that we're not actually using a real database. So at the moment when you post a record through for a player, one of the pieces of information that needs to get filled in but isn't getting filled in by the user is an ID. That's a system generated field. Now if we had a proper database set up, the database would handle that and assign a unique ID. but we haven't got a proper database in place, so we have to perform a little bit of a hack to simulate that same behavior. So let's go back to the code, and that's what this next ID helper is. So let me just copy that piece of code in and explain what it does. So if we just paste that below the current method, here's our little private helper method, and what it does is it goes and looks at the in-memory database, the list of players, and it goes and gets the maximum ID it can find out of that database. So if we go and have a look at the database at the moment, the maximum ID is number 3. So when you call this the first time round, this will return 3 into the last ID, and then it will return 3 plus 1, which is 4. So 4 will be the next ID of any record that we post into the system. So that's what we're doing here, is in the payload that's coming in called player, it's got an ID field that's not getting set by the user's input. We're calling this method, and that will assign 4 into the ID field. Thereafter, it's quite straightforward. What we do is we go to the in-memory database, the list of players, and we say we want to add a new player, and the new player is the player that we pass in the payload with our newly assigned ID field. Then all we do in the end is we just return back something to the caller. So in the first instance, we're just going to carry on with the responses we've been using up to this date. We're going to pass back a HTTP OK with the whole list of database entries for a player. So let's just try this one out in Swagger and see how it behaves. So you can see in Swagger now we've got a new endpoint up here called post. Has the same sort of route as the others. The thing that makes it different is that it is using the post verb. When you click on it and try out, you'll notice that it has no sort of text boxes for query strings and things like that. It's wanting you to post some information into the body, and it's giving you an idea of what the shape of that data should look like. So let's fill this one in. The one bit we don't need is the ID, because that is a generated field. In later videos we will get around that using data transfer objects, but for now we'll just delete it and we'll insert some data into here. So we'll say this is Harry Kane for the surname. We'll leave the sample email address as it is, that's fine, and we'll create a bogus phone number, and we'll say that he's active in the system. Then we'll go execute. Before we do execute, I might just put a breakpoint in the code just so we can step through it. So we enter the routers work correctly from that URL post. We've hit this action result in our player controller. We're passing in a player. If we have a look at the payload, we can see we've got all the information apart from an ID, which is an automated field. Like we said, the user's never going to know what the next ID is, so that's fine. And then the first thing we're going to do is call our little hack, our workaround method. So let's just step into that one. That's going to look in the database to see what the last ID is that it can find, and the last ID it can find is 3, which is correct, because if we look in there of our hard-coded list, Ben Stokes 3 is the highest number. Go back to our code, it's going to add 1 onto that and return 4. So this now, from being 0, will now be 4. There we go. Then we're just going to assign the whole player payload object into the list. So at the moment the list has 3 in it. By running this statement, the list now has 4 in it, of which the last one should be Harry Kane. That's good. And then all we're doing at this point is we're returning a 200 success, everything worked as expected, back to the caller, and we're also returning back the whole database of players. Scroll down, and there we go, John Smith, Peter Parker, Ben Stokes, Harry Kane. And that will also show up in the overall get call as well. There we go. So that's all good. So if we go back to the code, let's just close this a second, and back to my text file, we've now fulfilled the HTTP post. So the next logical step is to be able to delete existing players from the system. So we're now moving on to this one. So let's go back to our controller. Again, I'm going to paste in some code, and then I'm going to show you what it does. So the first thing to note is that we are using the HttpDelete verb. We've created another action result, we've called it delete player, and to delete a player we need to say which player we want to delete. So we're passing in the ID of the player we wish to delete, which is what this bit is. So based on that we need to create a unique delete endpoint signature. So we have a route that will say API/player/ID, which we'll see when we call up Swagger. So in the implementation of this, what we're doing is we're creating a variable called player to delete. We're going into the memory database, getting the list of players, and we're trying to find the first player in that list that matches the ID that we've passed in to the method. There are 2 outcomes that can end up in the player to delete. We can end up with the player itself in this variable, or that it cannot find that player, in which case the default value will be null. So if the default value is null, we need to do a check for that null. So we say if player to delete equals null, means we couldn't find a player to delete, so we're going to return back to the caller a not found, and a not found is a HTTP status code of 404. So that's what will happen there. However, if we can find a player in the database, what we are going to do is call the database.players, and we're going to call remove, and we're going to remove that player. Then we're done. So all we need to do then is tell the caller that it all worked correctly. So we return an OK at this stage, which is a 200, and return the list of players left in the database. So let's try this one out. Again, we'll put a breakpoint on and see what happens. So as you can see, we've got another endpoint in the Swagger UI. It's quite nice that it's highlighted it in red, as deletes can be quite destructive. In a finished API, probably the delete would be locked down, so you have to log in to use it, as otherwise anyone hitting the endpoint could delete records from your database. And probably the only people who would be deleting information out your database are people who are administrators of our sports management system. So let's expand this one out. Oh, one thing to say before we do this, because this is an in-memory database, every time I stop the web API and restart it, it loses any information that we've put in other than the hard-coded list that we start off with. So if I just show you, we should only be back to 3 users again, which are the hard-coded users that were put in memory. So Harry Kane has disappeared from our previous post demo. So what we'll do in this instance is we will delete Peter Parker, which is ID 2. So if I expand out the delete endpoint, go try out, enter 2 in there, hit execute, and we hit our delete route. We've got the ID of 2 passed in, and the first thing it's going to do is try and find record or player 2 in the database. So that's what this statement is doing, this link statement. If we F10 on that, did it find anything? Yes, it did. So it's not null. It's found Peter Parker as an actual object. So we won't trigger this if statement. Instead, we will jump past that, and the moment our player list has 3 in it, but we're going to say remove this player that we've just found. So all of a sudden our list now has 2 in it, and then we're going to return the whole list back to the caller. If we now look at what's come back, we've got 1 and 3, but we've got no 2, which was Peter Parker. So that's good, that's fulfilling the delete requirement. Let's stop the code and move on to the next item. So the next item in the list is to be able to update an existing player that's already in our system. So say we've called Peter Parker the wrong name and their actual name is Paul Potter, and we want to change that. So let's implement a update. To do an update, you have 2 approaches. Probably the most common one, which will update everything to do with an existing resource, is the HttpPut. So let's use that one. So again, I'm going to copy some code in just to save a little bit of time and then walk through each line. So if we have a look at this now, you can see the first thing is that we have a HttpPut. So that is the verb that we are using in this particular call. And this one has a bit more of an interesting signature. We've given it a name of update player, and we're passing in 2 parameters this time. We're passing in an ID, which is the ID of the player that we want to update. That will appear in the URL because it's matching to this route here. And secondly, we are passing some data in the body, which is the player information. And this player information will be the correct player information, or the new player information we want to overwrite the database with. So if we then go and have a look, this one I've added in a few more conditions just to demonstrate different HTTP codes that you can return back to the caller. So the first statement on line 69 is a little bit contrived, but I put it in place just so you can see one example of a bad request. So in this statement I'm saying if the ID on the query string, which is this parameter, does not match the ID that is in the body of the request, then we're not talking about the same player that we need to update. So we've got a mismatch between what's in the URL and what's in the body of the request. So in that instance, what we're going to return is a bad request, and a bad request is a HTTP 400 error with the message ID mismatch. If we get past that test, the next thing it will do is it will go off into the database and it will try and pull back that record based on the ID supplied, very much like it did in the delete statement. So if it's successful, we'll end up with the player we want to update in this variable called player to update. If it can't find a player for that given ID, we will get a variable that has null in it, which means on line 74, player to update equals null. If that is true, we will return a HTTP status 404 not found, with a custom message saying could not find the player to update. If everything is still good and we have found a player to update, we then move on to line 78. And in line 78 we are again doing a little bit of hack style code, as we haven't got a database. We're having to hold on to the existing ID so we can reuse it in how we've implemented our update. So in our update here we are actually removing the old player's record and reinserting it with the new data that's come through in the payload, but we're putting the old ID in place. So that's what we're doing here on line 78, is make a note of what the current player ID is and hold it in old ID. Go into the database and remove that player that we found. Then from the payload, we will assign the old ID back into the ID field, and then we will re-add the player back into the in-memory database, and finally we will return everything is fine with the 200 code and return all the players in the database. So the update, how it's been implemented, is a little bit of a mixture of a delete and a post all in one. So let's put a breakpoint on this and try it out. So you can see we've got yet another entry called put. So what we'll do is we'll update record 2, which is Peter Parker, and we'll change his name to Paul Potter. So let's go try out. Again, you can see this time we have got a box that it wants an ID, so we'll put 2 in there. And here is the information we're going to submit up to the server that is going to replace the existing resource, Peter Parker, with Paul Potter. So first of all we'll put 2 in here. We'll say the first name is actually Paul and the surname is Potter, and we'll leave all the rest because we're not interested in that, but we'll also update these fields as well. We will change that one to false. We'll hit execute, and then we hit our put endpoint, and you can see from the URL we're getting the value of 2, and from the body we are getting a player object that also has an ID of 2 and the new information that we want to submit into the database. So on line 69 we've got this contrived check that is saying, is the URL ID the same as the payload body ID? If they're both equal to 2, so it's not going to hit this bad request, so we'll jump over that statement. The next thing is, can it find a player with an ID of 2 in the existing database? Which it can. So now we've got a player object from the database that is Peter Parker, and now we're going to swap out Peter Parker for Paul Potter. So it has found a player for ID 2, so it's not going to hit this null check. This is where we're just storing the old ID just to be using it later on, which is a bit of hack code as we haven't got a proper database in place. The next thing is, in our list, in memory list of players, we currently have 3 players. We're now going to remove Peter Parker from the list. So now we have 2 players, which are John Smith and Ben Stokes. Then we're going to re-add the player that is the payload with the ID of 2. So all of a sudden player 2 will be Paul Potter rather than Peter Parker. So let's just add that in. As you can see there, the list's gone back up to 3, and then we return the whole database back to the caller. We scroll down, you can see John Smith, Ben Stokes, Paul Potter. And it's in this order because I haven't put any sort of sorting on it, so the last record regardless of its ID that's modified, will appear at the bottom. So that is the update as well. So let's just close this. Let's go back to our README file. So we've now added a new player, we've deleted a player, we've updated an existing player using the put. So I said there's two ways of being able to update an existing resource using a web API. There is HttpPut and there is HttpPatch. How is it different? So I've got a little definition of both here. I'm not going to demonstrate HttpPatch in this particular video, but I'm going to describe how it works, and then you can decide which one fits your needs best. So HttpPut is a method for modifying resources where the client sends data that updates the entire resource. Put is similar to post in that it creates resources, but it does so when there is a defined URL wherein put replaces the entire resource if it exists, or creates new if it does not exist. So in essence, it will update every field even if every field hasn't changed. So it's a little bit like an update statement as shown here in SQL. So this is the one we've just used, whereas the patch is defined as follows. Unlike put request, patch does partial updates, e.g. fields that need to be updated by the client only. That field is updated without modifying the other fields. So it's far more specific in what it updates. So in this one we're updating each of the fields A and B. This one we're just saying update A please for this given resource. So that's the difference. More information on that can be found by just googling around, but yeah, in essence they both let us update our resource. So that's good. So in essence now we have a full CRUD, create, read, update and delete. So this stands for creating data, which is using the HttpPost. The R stands for reading data, which is using a HttpGet, which we discussed in the previous video. The U stands for update, which is either using a HttpPut or a HttpPatch. And the D stands for delete, which is using the HttpDelete verb. So we've now got something that lets us fully administer our data. So if you go no further with this series, this video and the previous video gives you enough information to get up and running, have a bit of an understanding of what Web API is, but I would suggest that you carry on following on through the series, as at this stage what we produced is demo code. This code is not really suitable to put in a production ready environment for no other reason than, for a start, we haven't got a database to persist the data. It's not much use just holding it for the length of memory, then when the machine reboots it loses everything. Apart from that as well, there's several other things that we could do as best practice and good citizens, splitting out our concerns and our responsibilities, having some testing, making use of solid principles. So please carry on following along through the video series to get a more refined and finessed solution. Before I finish up today, I just want to go back to our controller and talk a little bit more about HTTP codes. If we go back to our post method, which is this one, up to now we, just for simplicity, have always been returning a HTTP OK, a 200. Now this is fine, but there may be better codes that you can return. And one thing that I don't particularly like about this is that we return a 200 code and then we return the entire database of players, which is fine while we've only got 3 or 4 in there, but say we've got a player registry of 50,000 players. That's not particularly efficient each time, returning every single one of those to the user. So let's swap this out for some other options. So what I'm going to do is I'm going to comment out this line, and I'm going to reinstate this line. So rather than returning a OK 200, I'm returning a no content value, which if we put the mouse over this returns a 204. So again, based on our rules and in our cheat sheet, anything that starts with a 2 is good. This is just a different 200 code. So like it says on the tin, it will perform the action. If everything is fine, it will return a 200 code or a 204 code, but it won't return back any content to the caller. So let's just try this one out. So on the post, go into here. We're not particularly bothered about putting in some meaningful information. That's good enough. We just hit execute, we hit the breakpoint, and this time we're going to return a 204. Hit F5 to return back to Swagger. Scroll down, we get a 204, which is a no content, and you see there is no other information returned, which may be perfectly valid for what your use case in your application is for. So that's one alternative, and that is a better alternative than returning the whole players database. Let's go back to the code and offer up another HTTP code status. So if we comment this one out and reinstate this one, I can walk you through what this one means. So what this one is going to do is it is going to return a 201, which is I've created something status. And what it's going to do based on this return created at action is it is going to call another endpoint, get player by ID, passing in the new ID that's generated and the player. So we'll get just the new resource that we've just posted in back to the calling application. So let's try this one out. Let's use the post again. Let's go try out. Let's submit something more meaningful this time. That will do. And then go execute. We hit the endpoint. This time we are going to return a 204 code. Hit F5. Scroll down. Sorry, I apologise, not a 204, a 201 code created, and the created just returns back the resource that we've just created and none of the other ones. And you can tell it's done that because we submitted this data, it's returned back this data, which looks exactly the same except for this generated field, the ID, which the database or the mock database is handled. So that's good as well. So like I said before, on our cheat sheet, bear that in mind. It's also worth going off to the actual Wikipedia page, which goes into far more detail of which of the codes to use. So for example, for a delete, probably a 204 might be quite good, no content. 201 is quite good for doing posts, but really it's entirely up to you. Read through, see which one best suits your needs. In this video we've also talked a little bit about bad requests from the client, so we've simulated a bad request where the data is wrong. We'll do more about that in future videos. We haven't done anything with unauthorized yet. We have done stuff with page 404 not found, which is probably the most well-known HTTP code because you often see it for web pages that no longer exist. Congratulations, you've come to the end of this video, and more importantly, we've fulfilled all the learning outcomes. So you now have a fully functional CRUD web API. So at this point, you've got enough to go away and build your own web APIs, but I encourage you to stay throughout the rest of the series where we will turn this demo code into more production ready code through the use of separation of concerns, best practices, solid, and actually using a proper database. So I'm the Hawaiian shirt coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.